And just to review what we've seen so far with one variable equations, we covered that they come from where? From a scale, is that correct? And then we said that our objective was what? I can solve and graph one variable equations. Read together, 1, 2, 3. I can solve and graph one variable equation. So we're still on one variable equations. So get a Freire model. Ready? And in the Freire model, I want you to write one variable equations. So give yourself about 30 seconds and start thinking, what would be a definition for one variable equations in your own words? Don't look at your notes. In your own words, what would be a definition? If you can't recall right away, come up with at least 2 examples and 2 non-examples. And then I'll ask you to share with your neighbor so that they can help. 30 seconds, go. All right, check in with your neighbor and see if they have a definition similar to yours and some example, non-examples. And then after that, come up with 3 hashtags together. See what you get. Go. Okay. I need a volunteer for the definition. Sebastian. Two expressions. Instead of the word with, what would you replace that so we know that it's one variable equation? So you said 2 expressions with one variable. Okay, so far so good. But what would we replace this word with so that we know it's a one variable equation? Well, one variable is an unknown. 2 expressions, what? 2 expressions. 2 expressions, what, everyone? Equal to each other. Thank you, Julianne. Equal to each other. Remember that? They need to be equal to each other in order to be a what? An equation. Let me see, an example. Pass it to someone, Sebastian. Luke. Just give me an example of an equation. 2x plus 3x equals 5x. All right. Yeah, is it an equal sign? Yes. Does it have 2 expressions? Yes. Another example. How about Julian? Go.
A minus 3 equals 6.
Thank you. How about a non-example, Ryan? Ryan, non-example? Sorry? 8 minus 3. What? Equals 6. Hands if you agree with that. We're trying to find non-examples of one variable equations. Non-examples. Who can fix this one? We can use this one, but who can fix it to make it a non-example? Juliana. Take out the equal sign and replace it with what? An inequality? Okay. All right, that's a non-example. Can you give me another one? Donovan. 2x what? Squared equals 4. Tell your neighbor why this is not a one variable equation. All right, 3 hashtags. Can you give me one, please, Savannah? Hashtag operations. Okay. A little bit more specific for equations. Who can give me a hashtag? Chris. it was a hashtag operation. All right. Let's see who's over here. Roberto. Hashtag what?
Hashtag one variable.
One variable. Very good. Pretty good. How about Sky? Hashtag what? Okay, I'll start somebody off. Here he goes. Hashtag no what? No Ryan. No inequalities, all right. I'll take that. How about no expressions? Does that make sense? So any of those hashtags will work. All right. Now that we got that done, our steps we already know: simplify, isolate, plot, and check. Okay. So before we get started, look up, please. Don't copy this. Look up to the screen. We already covered stuff that looked like this. Yes. Look up to the screen. Now we're moving on to stuff that looks like this. We're done with this. We're moving on to this. We're done with this, and we're moving on to this. Do you guys see it? You guys don't see it? Look up to the screen. We're done with this, and we're moving on to this. All right? Yeah, two-step equations. So look up, please. Before I get started with two-step equations, let me give you a hypothetical situation. Let's say Wyatt. Let's say Wyatt, he wants to give this girl a present for Christmas exchange. You know how they do present exchange? And so he goes out, and here it is. Let's see what I do with this.
The flower?
The box.
Why is the box apart? The box. Because where is the box? The table.
All right, so he gets the box, and he's talking it over with his friends, and they're like, so what are you going to put in there? And he says, it's confidential because I don't trust you guys. You guys are going to go tell everybody that you know. Not that it happens here. So then he says that he doesn't know. So when his friends are telling the story, he's going to tell people, there you go. So what was in the box? Oh, what was in the box was X. It's an unknown, isn't it? Because we don't know. All right. So he's going to close the box, get it ready to make it look nice. What does he need to do?
Wrapping paper.
Wrapping paper. So he's going to get some shiny wrapping paper, places it there in the center. He's going to start wrapping this up pretty good. From there, he's going to get a nice bow. Here it is. Be nice. All right. So I'm trying my best over here. So at the end, once he has it all complete, it's going to look something like this, nice and shiny. There it is. Oh, the bow. My bad. There it is. All right. So, and by the way, this girl that he's doing the exchange with is one of his neighbors, but they don't know. It's one of those that they don't know who it is, right? So, but he wants to surprise that person, so he goes and knocks, and all of a sudden he starts getting nervous as to like, oh my goodness, what am I going to say? So he does have you guys seen Napoleon Dynamite?
Oh, yeah.
When they knock and they leave the president on the floor, the cake, whatever, and they run to go hide and see through the bushes, that's what he does. He goes, hides, and here goes the girl. She opens up, looks at the president, she's like, what? She gets the box, and with the bow. So what do you think will be the first thing? Well, be nice, first of all. What do you think the first thing she's going to do? No, not throw it away. Be nice. She's going to try and find out, well, wonder what's in here. So what is the first thing she does with that? Open it. She takes off the bow. That's the first step. She takes off the bow. The second thing she takes off is the wrapping paper, and now she has access to the box and find out what's in it, right? Well, guess what? The reason I started it like this, so that you understand how to find the value of x. Because that's what we're trying to find here. Is that correct? The value of this x. Equations work the same way. Look. Check this out. I'm not going to worry about this, but I worry about this as to how am I going to undo this to find the value of x. So I'm going to work myself backwards. So if I work myself backwards, check this out. Here I started with x. From there, if I add the wrapping paper is multiplication and division. And the bow is usually addition and subtraction. So look at this. What would be the first thing that we take off from here if it was a present? The bow, which is what? Addition and subtraction. Work our way back, and the last thing we would do is multiplication and division. Does that make sense? And that's a good way of thinking about it when you're undoing these equations. So copy this, please. Example 2Q. Example 2Q. We got 3x plus 2 equals 25. And we're going to do this one using all four steps. So, first things first, line down the equal sign. Next, let's identify the operations. What operation do you see here? Addition. What is the other? Multiplication. So where do I start? Addition. So what is the inverse? Minus 2 minus 2. We're left with 3x equals 23, Michael Jordan. And what's our last step? Divide by 3, because we have multiplication. We need to undo that. So this is x equals 3 fits into 23 how many times? 7 and 2 left over, or 7.6 bar. Let's plot our point. We got 0, 1, 2, 3, 4, 5, 6, 7, 8. Here's 7, here's 8. 7.6 is 7 2/3, not halfway, a little bit more. It's about right there. Yes? And what's our last step, everyone? Check. So we're going to write our original equation, 3x plus 2 equals 25. And then we're going to write 3 and then open a parentheses for the x plus 2 equals 25. What goes in the parentheses? 7 2/3. All right. So question, can I multiply this times a mixed number? No, we need to change this to an improper fraction, right? So this becomes, again, 23 over 3. Bring everything else down. So to multiply, I put that over 1. Do you see the giant 1 here? Yes. So we're left with 23 plus 2 equals 25. Is 25 equals 25? Yes. So here the point was that I wanted to make sure everybody understood that you need to write your operations first and then start and work your way backwards. Does everybody understand? Okay, do this next one by yourself. Example 2, Super Q. Let me zoom in. 2, hey, Super Q, there it is. 12 equals 4y minus 8. Do that using 4 steps. Ready, go. Let's see, what you get for this one, Daniel? Hanny, we got y equals 5. That is incorrect. What you get for this one, Christian? We got 5 equals y. That is correct. Once again, don't start flipping stuff over because that's the way you feel comfortable. I want you guys to see it both ways. I'm going to give you stuff that has on the right side of the variable and on the left side of the variable. Are we there? Please, pretty please. All right. Copy this next one. Negative 5x plus 12 equals 37. See if you can do that one a little bit faster. For that one, don't plot it or check it. Just solve it. You have 30 seconds. Negative 5x plus 12 equals 37. Copy that and go. All right. Tanya, what'd you get?
I got x equals 5.
Hands if you got, x equals negative 5. That is correct. Okay, we're done with these. Now we're moving on to this kind. Example 3Q, copy this one. 3Q. Once again, the process is you draw your line down, identify the operations, and start working your way backwards, right? Be careful with this one because it does have a little curveball. Don't say it out loud if you see it. Copy and go. And then I'll go over it. All right, here it goes. I'm going to go over this one. I won't call on anybody to not embarrass anyone. So here it goes. Look up. Line down the equal sign. I'm going to identify the operations here. First of all, I see a variable with a negative in front of it. Therefore, there has to have a coefficient, doesn't it? What is a coefficient?
1.
And it becomes what? Negative 1 times a. So therefore, this is multiplication. What is the invisible sign in front of the 8? Addition. So where do I start? With positive 8. What is the inverse? Minus 8. Minus 8. We're left with negative 1 times a equals 6. What is the last step? Divide by negative 1. Divide by negative 1. A equals negative 6. Hands if you got that. Okay. Copy this next one, please. Like I said, be careful with these. Write out your operations and work your way back. Example 3, Super Q. Negative 3 equals m divided by 4 minus 6. Copy that. And just solve it. You don't need to plot or check. Just solve it, please. Ready, go. All right. Answer. What'd you get for this one? About Chris.
M equals 12.
Answer, we got m equals 12. That is incorrect. Donovan. 12 equals m. Hands if you got that. That is correct. Remember, stop messing around with the order. Leave it the way it is, please. Pretty please. All right, look at these next two. Don't copy these. Look up. But I want to see if you see what I see. Look at this one. Tell your neighbor, what operations do you see here? Okay, I heard addition, yes?
Yeah.
And I heard multiplication.
Yeah.
That is correct because there's a negative 1 here multiplying the a. Once again, be careful with these. Let's go to the funner ones. Copy this one, example 4. We got solve the equation 2/3 r plus 3/4 equals 7/12. Copy that. Only copy it, and I'm going to go over it. Okay. Writing utensils down. Look up, please. So there's several ways of approaching this one. I'm going to give you first one way, which is, I know you guys love fractions, but instead of working with fractions, I'm going to show you a step. I'm going to show you a step as to how to get rid of the fraction. Here it goes. Look up, please. Step number 1. You need to, I'm going to write a little note right here, asterisk, heart. I'm going to put ID, the common denominator. Identify the common denominator. So let's see. Look up, please. What is the common denominator of these three? 12. I'm going to take 12 and I'm going to multiply the entire equation. Look up, please. 12. So, when I distribute the 12, look at here. This becomes 24 over 3r plus 36 over 4 equals 84 over 12. Now, what do you guys notice stayed the same? The denominators. Why? Because when we multiply times a whole number, we can write this over 1. That's why all the denominators stay the same. Does everybody see that? Now, why do we do that step? Because now we can simplify this. This becomes 8r plus 9 equals 7. Everybody see that? Okay, copy that, please, and then we'll finish it up together. So from here, we draw a line down. What operations do we see? Multiplication and addition. So where do I start? Addition. So what do I do at that step, Alyssa? Subtract 9, subtract 9. This becomes 8r equals negative 2. Continue, Sebastian. Divide by 8 on both sides. R equals negative 2/8. Am I done? No. No? So therefore, R is equal to what, everyone? 1/4 or negative 0.25. We got this? Okay? Yeah.
I don't know the way I did it in equal to or more amount of work, but I converted all the fractions, like the denominator, all the denominators into the
Okay, thank you. Home play for tonight. It's play sheet 2.4, and you're only doing numbers 1 through 13. They're over here. There is no tutoring today. I have a meeting. Enjoy your home play. See you guys tomorrow. Bye.